Hello grade 10s, we're testing out some video options and we're going to skip ahead to chapter 5. So we're starting with 5.1, representing relations. A few definitions, and you can print off the note page that has also been attached and fill these in as we go. So first we have a set, and a set is a collection of distinct objects. So we could be talking about the set of colors or the kinds of dogs. Set notation is how we write elements in a set. So an example of that is with curly brackets, the numbers 1, 2, 3, 4, and 5. So curly brackets must be included in set notation. Next we have an element. An element is one object in a set. So for example, the number 5 is one of the elements in the above set. We also have a relation, and a relation is how elements are related with those of another set. One more thing to include is that the order of the elements does not matter. So the 1, 2, 3, 4, 5 could be in any order and it's still the same collection of elements. Let's move then to our first example. Example 1 is that fruit can be associated with their colors. Consider the relation represented by this table. So we have some fruit and we have their colors that match it. We're going to start by describing this in words. So we're going to say that fruit may have the color, and I'm going to say color. So what I mean by this is that apple may have the color red, or blueberry may have the color blue. So you can insert different words from the fruit column into where it says fruit, and the color column in for where it says color. We can also write this in set notation with ordered pairs. So what I would do then is write a curly bracket, and then inside I'm going to write a round bracket, and I'm going to say apple, comma, red. So what that means is that apple is an item from the first column, and red is the item that matches it from the second column. I'll put a comma and then do the next one. So it would be apple, comma, green. And we will continue that through all of the pairs until we get to the end, and then we will finish it off with a curly bracket. Your curly brackets do not need to be perfect. We're then going to do the same set, but represented as an arrow diagram. So in an arrow diagram, we make two large circles. The first circle is going to have the fruit in it, and the second one is going to have the colors in it. So we'll write those down as follows. And if you need some more time, you can pause the video here to finish your diagram, and then you can catch back up with us. So we're going to then associate each item with their option. So an apple could be red, so I'm going to draw an arrow to red, but the apple could also be green, so I'm going to draw an arrow to green. The blueberry is blue, the cherry is red, and the huckleberry is blue. So by looking at the diagram, you should be able to see which fruit is which color. And we're also going to put the words up here, so may have the color, because that's what's happening here with the arrows. The fruit may have the color of color. Now our next example, just a few little notes. When the elements of one or both sets in a relation are numbers, then the relation can be represented as a bar graph. So I'm sure you've seen a bar graph before in Math 9, but you can just put the numbers on the sides and then draw your bars. Our next example is example 2. It says different breeds of dogs can be associated with their mean heights. Consider the relation represented by this graph and represent the relation as a table. So first of all, I have a graph and now I need to interpret that information as a table. So in my table, I'm going to put on one side the breed and the other side the height. So we'll write down all the breeds and then their heights. So the hound is 75 centimeters tall, the Chihuahua is 20 centimeters tall, then we have the Corgi is 30, the Golden Retriever is 60, the German Shepherd is 60, and the Malamute is 65. So that's how we would write this as a table. Now we're going to try the same set of data, but write it as an arrow diagram. So remember, in an arrow diagram, you do your two circles, and we're going to put the breed in the one and the height in the other. So we'll write that out. So again, pause the video here if you catch up. But finally, we'll just put our arrows. So the hound is 75, the Chihuahua is 20, the Corgi is 30, the Golden Retriever is 60, the German Shepherd is also 60, and the Malamute is 65. So just write your arrows to represent the relationship. The last way we're going to represent this same set of information is as a set of ordered pairs. So remember, we start by doing our curly brackets, and then in the inside, we write our information. So the hound is 75, and then list the next item. And once it's all written out, be sure to finish it off with a curly bracket at the end. Let's look then to our next example, example 3. So in this diagram, we're talking about Western Canadian cities within 1 hour driving distance from other Western Canadian cities. So describe the relationship in words would be something is within 1 hour of driving from something else. So we're going to list 2 ordered pairs that belong to the relation. So maybe we would say Humboldt and Melfort. So Humboldt and Melfort. That might be one ordered pair that fits. Maybe another ordered pair would be Humboldt and Saskatoon. And I'm sure you can think of many others that would be within 1 hour of driving distance from another. Now the final thing we're going to look at, this is a little bit tricky. This is the notation, how we write this. So for example, here I have -3 is less than x is less than or equal to 5. So if I were to draw that on a number line, I would have -3 and +5 on my number line. I'm looking at all the values in between -3 and +5, but since this sign is just less than, that means I'm going to draw an open circle at the -3, but since the 5 has a less than or equal to, I'm going to draw a closed circle on the 5. So when you're reading these, this means that all of your x's are in between -3 and +5, but it doesn't include -3. Let's try the next one. Our next example here shows that all of my x's are in between -2 and +5, but it doesn't include -2. So if I'm writing that, I'd say that -2 is on the small side, 5 is on the big side, all my x's are in between -2 and +5, but the 2 is not included, so I'm just going to do a less than symbol. And the 5 is included, so it's less than or equal to. Again, that's because there is a closed circle over the 5. Now this next one's a little bit different because it goes from 3 all the way off forever, so it never stops. That line's going to continue. So here, we would just have to write that all of the x's are less than or equal to 3. Again, all of your x's go from 3 and lower, and 3 is included because it shows that there's a closed circle. So all of these are called set notation, and this is when you're dealing with numbers, not necessarily dealing with cities or dogs or other things like that. Finally, there are some textbook questions that you can take a look at, so please complete at least 3 letters of each of the following. Thank you.